Norman Marshall of the Fire Research Station.
I work for the Active Fire Protection Systems section, where we're concerned with the spread of smoke onto escape routes. Now, here we have a small-scale model which we can describe the methods which go into smoke control in buildings. At the moment, we have what we regard as a 1/5 scale model, which has as its main part a corridor, and at the back of that corridor we have a compartment. Now, this compartment can represent a flat, or it can represent a hotel room or a masonette compartment. And the corridor then sides onto a shaft or staircase. First of all, we will switch the smoke on in the rear of that fire compartment and actually see the smoke actually passing into the corridor. And as you can see, the gas is spread laterally under the ceiling. They spread into this part of the building, where they spread up through the staircase, or it could be a shaft. As it flows down this end of the building, you can see it hits the far end of the building, comes down at low level, and then comes back towards the fire room. As the fire develops, as time goes on, this circulation is set up, a convection cell is set up, whereby the entire part of the corridor actually fills up with smoke, causing a smoke log situation. Right, so how do we overcome that problem? Well, what we can do is we can use what's called a compartmented type smoke control method. And this is where we introduce partitions every so many meters down the corridor. And these partitions contain the doorways through which people are able to leave and enter the corridor. As the smoke starts to develop again, it comes up to these partitions and the smoke is stopped and it's contained within the locality of this part of the building.
Because no smoke enters the lobby or staircase shaft, these form a place of safety, which people from the rest of the building can use as an escape route. This method is relatively simple and inexpensive to implement, and it's reliable. The main proviso is that the doors are smoke sealed. The other common method for multi-compartmented buildings is pressurization. A fan is placed where it can inject air into the staircase or shaft.
As you can see, we've got a repeat of what happened last time. Smoke comes through the cracks around the door, it spreads laterally, and when it reaches the compartment, you can see that the smoke is actually starting to pass through the cracks. We've deliberately allowed leakage around the door just to show you smoke passing into the adjoining lobby. If we now put the fan on, in other words, inject air into this part of the model through the shaft and therefore through the lobby, you can see that this smoke no longer passes onto the lobby because we've now introduced a pressure drop across the door. Effectively, what this is doing is overcoming the pressure due to the thermal pressures of the gases trying to force their way through the cracks. No smoke enters the lobby or the staircase, and in fact you can see smoke being pulled through into the corridor. We can further show how the system works by simply opening the door, and as you can see, even with the door open, smoke does not enter the lobby, and this ensures that if someone is escaping from the corridor, they can open the door, and even if they leave it open, there's no dangerous smoke endangering people on these safe escape routes. We can now show the system also working with the compartment door open. And what we will now do is we will now close that partition door and open the compartment door. And as you can see, the volume of smoke is much larger now because we've opened the door, and much larger quantities of smoke move into this section of the corridor. It fills up rapidly, but as you can see, even with the pressurization system on, no smoke enters the lobby. However, the system will break down eventually. If we now open the access door, which can be a double door opening, that then reduces the pressure drop across the door and thereby allowing the smoke to enter the corridor. And that's basically just showing the limitation of the system.
So far, we've seen how escape routes can be created in a multi-compartmented building. Now we'll look at the same problem in a large, undivided volume building. The model is reconfigured to represent a shopping mall, this time at a smaller scale, 1/10. An atrium section several stories high adjoins the mall. Advancements in glass technology mean that there's now a better chance of a shop front remaining intact in a fire, but the glass can fail, and some shops are open-fronted anyway. So our fire is simulated for an open-fronted shop to give the worst possible conditions.
So we'll first put smoke into the rear of the compartment as we've shown before, and as you can see we've now got a fascia instead of a door, and it's an open-fronted shop. As the smoke comes in, again it forms a layer, but the smoke actually comes down below the fascia, and as it does so, it spills under the edge and then rises up towards the ceiling and spreads laterally again under the ceiling. The smoke spreads down towards the remote ends of the mall, and as you can see, as it spreads towards that end, as it hits the end, it dips down and comes back towards the fire. On this side, the smoke spreads laterally, but in this case, because we've got an atrium building there, which is opened onto the mall, the gases spread into the building and they rise, causing severe smoke logging within the atrium. Now, the reason for this is that the fire basically is acting as a pump. It's trying to draw air in at low level, and because we've closed it off, it pulls the contaminated air back at low level and back towards the fire. Now, the danger here is that in the initial status, in the beginning as the fire developed, people walking in this direction will actually see a smoke front coming to them at low level. And if they're at this location, they'll probably walk back towards the fire. And so you've got a very dangerous set of circumstances occurring here. So how do we overcome this problem? Well, the common method for large undivided volume buildings is to use a ventilation system and reduce its spread. Firstly, you need to divide the ceiling up into smoke reservoirs. That means you need screens. Secondly, you need adequate air to come in at low level, and that means you need openings at both ends. Thirdly, you need adequate extraction in order to ensure that the gas lays well above the escape route. And by doing these three measures, i.e. opening the inlets, having screens and having adequate extraction, you can see that this gas layer has gone well above the escape routes within the mall, which basically is represented by the mall. And fourthly, and it's something which we can't show on the small scale, we've done it on large scale, is that you need sprinklers within the fire room actually controlling the fire. So the sprinklers may not put the fire out, but they will actually control it and limit the amount of smoke entering the mall.
For large undivided volume buildings, all these measures must be applied, or the system will fail, as can be demonstrated by reducing the effectiveness of each feature.
And as you can see, as we close it off, immediately that smoke starts to come down below the screen and back at low level, and thus creating a smoke log situation. Similarly, if we cut off the extraction rate, the gas layer would come down. If we didn't have sprinklers within the fire room, the fire could go beyond the fire room to flash over, in which case the system would break down anyway. And if we didn't have screens, what would happen is that the gases would go beyond this section of the shopping mall into other parts of the shopping mall and cause smoke logging at remote locations within the building. So all four measures are needed, and we'll open the inlets again just to demonstrate the safe condition which we just had a moment ago.
Whichever building and type of smoke control system is used, the objective is the same. In the event of a fire, people should have a clear escape route by which they can get out. It means that the fire brigade can reach the seat of the fire relatively easily, improving their chances of extinguishing it quickly. So a properly maintained smoke control system should save lives and property.